All right. In addition, remember, we can switch the order of the add-ins around, and our sum won't change. 5 plus 4 equals
9.
And 4 plus 5 equals
9.
It doesn't matter. In fact, sometimes it helps to switch the order of the add-ins. Why would saying 5 plus 4 help us work smarter than harder instead of saying 4 plus 5? Kaden?
Because if you just put up four fingers and then you add one,
If I put up 4 fingers and add 1, I'm going to get 5. But we're not doing 4 plus 1 equals 5. We're going to let Kaden fix his answer. Kaden, how come it makes more sense to say 5 plus 4 instead of saying 4 plus 5, even though we get the same answer?
because saying 5 plus 4 would be faster because it's not 4 seconds. Saying 4 plus 5 would take 5 seconds.
Exactly. If you didn't hear Kaden, he said that saying 5 plus 4 is only going to take 4 seconds. But saying 4 plus 5 is going to take 5 seconds. And that second that we saved, we can use to solve even more math problems. So remember, in addition, we can change the order of the add-ins, but the sum stays the same. Let's practice. Do whichever one you want. You can switch the order of the add-ins, or you can do it in the same way that it is. But remember, we like to work
Smarter, not harder.
You're going to say the sum, and then I'm going to say plus 1, and you're going to tell me the next number. Let's try the first one slow. 7 plus 3.
10.
Plus 1.
11.
Perfect. Ready to move a little quicker?
Yes.
All right. 6 plus 8.
14.
Plus 1.
15.
Good. 3 plus 5.
8.
Plus 1.
9.
Good. 2 plus 1.
3.
Plus 1.
4.
4 plus 6.
10.
Plus 1.
11.
9 plus 3.
12.
Plus 1.
13.
Good. 6 plus 4.
10.
Plus 1.
11.
7 plus 4.
11.
Plus 1.
12.
8 plus 8.
16.
Plus 1.
17.
5 plus 6.
11.
Plus 1.
12.
0 plus 5.
5.
Plus 1.
6.
5 plus 7.
12.
Plus 1.
13.
So what's 12 plus 1?
13.
Much better. 6 plus 7.
13.
Plus 1.
14.
5 plus 7.
12.
Plus 1.
13.
2 plus 0.
2.
Plus 1.
3.
3 plus 4.
7.
Plus 1.
8.
2 plus 7.
9.
Plus 1.
10.
9 plus 9.
17.
Stop and think. Stop and think. 9 plus 9.
18.
I love that mistake because...
Mistakes are how we learn.
Exactly. 9 plus 9?
18.
Plus 1?
19.
Much better. 4 plus 2?
6.
Plus 1.
7.
6 plus 3?
9.
Plus 1.
10.
5 plus 8?
13.
Plus 1.
14.
5 plus 9?
14.
Plus 1.
15.
3 plus 9?
12.
Plus 1.
13.
2 plus 8?
10.
Plus 1?
11.
9 plus 3?
12.
Plus 1.
13.
Now, I have a question for you. It's going to make you rack your brain for an answer. When would we need to be able to add 1 to 2 add-ins quickly? When do we sometimes need to add plus 1? In real life, in math class. Mark?
When it's like 9 plus 3?
If it's 9 plus 3, do we need to add plus 1 to that? When do we see 2 add-ins? Maybe this will help. And need to add plus 1. Jerron? When we regroup with addition. It's important for us, to be able to add that plus 1 quickly so that if it's 10 or more and we bring a 1 next door, we know exactly what the next number is. Great job to everyone who stopped to think about that. All right, here's another drill that can help us with addition. If I say 10 more, no, if the number is more than 10, say
More.
If the number is less than 10, say
Less.
And this is going to help us know when we should bring a 1 next door to regroup. 14.
More.
Good. 7.
Less.
11.
More.
Good. 12.
More.
So would we bring a 1 next door?
No.
Stop and think.
Yes.
Yes.
How come, Zanaya?
Because if it's two big numbers and if it's 12, we have to add a 1 to make it.
We're not adding a 1. I'm going to call on someone else, and I want you to listen really carefully because I'm coming back to you. The rule for regrouping is if it's 10 or more, we bring a 1 next door. And I asked if we saw 12, would we bring a 1 next door? Would we, Kelsey?
Yes, we could. Because if it was less, we wouldn't bring a 1 next door. But if it's more, we will bring a 1 next door.
More than what?
More than.
You said if it's more, we bring the 1 next door. If it's more than what? If it's more than 10, we bring the 1 next door. Zanaya, would we bring a 1 next door if our sum was 12?
Yes.
How come?
Because if it's more than 10, we would say 12.
If it's more than 10, what do we do with the 1?
We would put it in the 10th place and we would add it.
Yeah. Zanaya, you're exactly right. And Zanaya was a perfect example of someone who learned from her mistake. At first, Zanaya thought we wouldn't bring a 1 next door. But since 12 is more than 10, we bring the 1 next door. Great job to everyone who's showing agreement. Stop and think. Go.
Less.
Would we bring a 1 next
No.
door?
No.
No. Why not, Zanaya?
Because it's less than 10.
Perfect. It's less than 10, so we don't need to bring a 1 next door. Great job. Stop and think. Go.
Less.
Perfect. Stop and think. Go.
More.
Excellent. Now I told you all along that we can swap the add-ins around and it won't matter. 4 plus 5 is the same as 5 plus 4. But it's not like that with subtraction. With subtraction, we always have to subtract minuend minus subtrahend. We always have to go top minus bottom.
Not bottom.
You're right. We cannot switch their jobs. The minuend is always the top number that we take away from. The subtrahend is always the bottom number that we take away. We can do 5 minus 4. 5 minus 4 equals
1.
But if I hold up 4 fingers, can I take away 5?
No.
You can't do it. And when we're subtracting and we need to know if we should regroup or not, it's important to remember that if there's more on the floor, we go next door and get 10 more. We need to get used to knowing that we can't do it if the bottom number is bigger than the top number. So let's practice. If we can do it, I want you to tell me the difference between the minuend and the subtrahend. But if it's impossible, I want you to yell,
Can't do it.
Exactly. 9 minus 3.
6.
Yeah, there's more on the top.
No need to stop.
Exactly. How about 7 minus 7?
0. If the numbers are the same, 0 is the game.
Good. Back and slant. So far, we've been able to do it. If the more on the top, no need to stop. If the numbers are the same, 0 is the game. Stop and think. 4 minus 1.
3.
Yeah, we can do it. 7 minus 4.
3.
Fine. 1 minus 4.
Can't do it.
Someone who remembered that we can't do it, can you tell me why not? Why can't we do it? Sydney?
We can't do it because if you have 1 finger, you can't put up 4 fingers.
Sydney's right. If you have 1 finger, you can't take away 4 fingers. Sydney did a great job answering that question like a 2nd grader. Because we're all 2nd graders, and that's the great way to answer questions. But I was wondering if there's anyone who can answer that question using the academic language I've been modeling. So instead of saying the top number or the bottom number, to answer it with academic language. What do you think, Mark?
We can't do subtrahend minus minuend.
Exactly. Mark realized that we can't take the subtrahend and minus it from this minuend. The minuend is too small. Great job using academic language to answer that question. Let's keep going. 9 minus 8.
1.
Perfect. 0 minus 3.
Can't do it.
Excellent. Instead of me calling on somebody, I want you all to face your turn and talk partner, but don't start sharing yet. My question for you is, why can't we do it? And I want you to encourage your partner to use academic vocabulary to answer that question. Why can't we do 0 minus 3? Go.
We can do 0 minus 3 because...
Stop, look, and listen. When we turn and talk, it's important to speak at a noise level 1 so that only you can hear your partner and not the other kids on the carpet. Go.
We can do 3 minus 3 because if you have 0 is too low the subtraction is too low to minus. The minimum is too low to take from the subtraction.
Bryson, why can't we do it?
We can't do it because the minimum is too small for the to take away 3 because it's impossible because you won't have any more fingers.
Great job. Bryson's so right. If we start with 0 as our minuend, it's too small to take away 3. And 3 is our... What's 3?
Subtract.
What's 3, Bryson?
Subtract.
The subtrahend. And if you already knew that, you can show you know with an agree sign. Great job. All right, back in slant. Noise level 0 in 3, 2, 1. 6 minus 5.
1.
5 minus 6.
Can't
Exactly. It's not the same as addition where we can add them either way. We can't subtract 5 minus 6. We can't do it. The minuend is too small. The subtrahend is too big. The difference would be impossible to find. 0 minus 1. Excellent. So this drill is going to help us when we start subtraction with regrouping. We're going to do another subtraction with regrouping drill as soon as everyone's back in slant. So you're sitting up, you're listening actively, you're raising your hand to ask and answer questions if you have them. You're not talking while the speaker is talking. You're tracking the speaker, Kirby, and paying attention. 1 less.
8.
10 more.
19.
When we subtract with regrouping and we go next door to get 10 more, this is exactly what we'll be doing. If we have a 9 in the tens place when we regroup, it will become an 8 because we'll take it away. If we have a 9 in the ones place when we regroup, we're going to add a 10 to it and it will be 19. Very good. Oh, wait. Thank you. 1 last.
3.
10 more.
14.
I need everyone participating. 1 last.
0.
10 more.
11.
1 last.
5.
10 more.
16.
1 last.
4.
10 more.
15.
Good. 1 last.
6.
10 more.
17.
1 last.
8.
10 more.
19.
1 last.
7.
10 more.
18.
Last one. 1 last.
1.
10 more.
12.
Excellent. All right, it's almost time for our next criteria where we represent addition and subtraction with and without regrouping using discs and the algorithm with the team. So very, very quietly, moving in safe space at a noise level 0. I want you to get your right and white and come right back to the carpet. I see Cindy moving in safe space. Bryson's already back on the carpet at a noise level 0. Mark and Darian and Dante were first-time listeners. Maria's a first-time listener sitting on the carpet at a noise level 0. Duran waited until an appropriate time to put his blazer away. Now he's coming back to the carpet at a noise level 0. All first-time listeners will be sitting on the carpet with a right wipe in their lap by 10, 9, 8, 7, 6, 5, 4. Put the pen back in. Did not tell anybody to pull their pen out. In 3, 2, 1. I want all eyes on Zanaya. I like the way that her hands are folded on top of her right and white because it's not time to use them yet. They're going to be here ready for us when it's time, so we don't have to make another transition. But don't let it distract you or bother you. Keep your hand folded in your lap until it's time to use the right and white. Before we practice our algorithm and representing our discs, we're going to review the rhymes that help us every time. Here we go.
Addition and subtraction will be fun if you always remember to start with the 1. If there's 10 or more, bring the 1 next door. If there's no more on the top, no need to stop. If the numbers are the same, 0 is the game. If there's more on the floor, go next door and get 10 more.
Stop, look, and listen. I'm going to show the first problem. I want everybody to start representing it with place value discs on their work mat side. Go. 54 plus 25 on your place value mat. 54 plus 25 plus 25 on your mat. Good, Aaron. Mark plus 25. Good. Good. Beautiful. Excellent. Yeah, if yours looks like mine, you did it correctly. Plus 25, Joseph. 54. 54. So there's no hundreds in this number. We just have tens and ones. 54. So there's no hundreds. 5 tens. 4 ones. And we're adding 2 tens, 5 ones. So 2 tens, 5 ones. Stop it, John. Erase that what you just did. We're adding. We don't need to regroup them to the ones. Line up 54 plus 25. All right, since we're adding, we represented both parts, both add-ins, the 2 parts, and we're trying to find the whole. Let's count up how many ones we have, because addition is fun.
If you start with the 1.
Exactly. Count up 4 ones plus 5 ones. What is it?
9.
9 ones. Everybody put 9 on your work mat. Stop and think. Did we have to regroup any discs?
No.
No. Why didn't we bring the 1 next door? Zanaya, how come we didn't have to bring a 1 next door?
We didn't have to bring them 1 next door because it was not more than 10.
You're exactly right. It wasn't 10, so we didn't have to regroup. Great job, Zaza. All right, and in the tens place, we have 5 tens plus 2 tens.
7.
7 tens.
54 plus 25.
You're right, Kelsey. All right, clear that. We're going to practice the algorithm for addition. We always line up our problems on
H-T-O.
Do it. H-T-O. Where does that 5 go? Everybody?
In the tens
In the tens place. 54 plus 25. Don't solve it yet. I just have a question. How come I couldn't put my 54 here? Malaya?
Because they don't look like 540.
Exactly. If I put my 5 in the hundreds place and my 4 in the tens place, that would be 540, and that's not part of our problem. And I know Amani was going to say the same thing. Great job, Amani. All right. We always start in the ones. Now, I have a question for you. If we're trying to work smarter, not harder, should we do 4 plus 5 or 5 plus 4?
5 plus 4.
All right, let's do it. 5. That is quicker.
6, 7, 8, 9.
There you go. And should we do 2 plus 5 or 5 plus 2?
5 plus 2.
You're right. 5, 6, 7.
7.
Excellent. Did we get the same answer as our
Yes.
disc? Yeah, then we did it correctly. We checked our work and it was perfect. Clear your board and flip it over. We're going to represent some more discs. Great job to all the first-time listeners. Okay. Oh, I made it a harder one. 287 plus 36. 287 plus 36. Much better, Joseph, here. I can see. All right, let's start in the
Ones place.
All right, I know that we have 7 in our first ones place. Let's count on 6. 7.
8, 9, 10, 11, 12, 13.
Uh-oh.
We gotta regroup.
We do have to regroup. Kelsey said we have to regroup. How come? How do we know we have to regroup? Darian? It's more than 10. So let's start with our 7 that we already know. What goes with 7 to make 10? 3. So take your 7 and circle 3 more. And then we're going to regroup it next door and change it for a 10. Excellent. All right, let's count the ones. What's left in the ones place?
3.
3, you're right. All right, now let's go over to the tens place. Let's count it up. We started with 8 tens. Let's keep counting. 9, 10, 11, 12. Bryson said regroup. Kelsey said regroup. Why do we need to regroup?
Because it's more than 10.
It's more than 10. So let's get 8. And what goes with 8 to make
2.
10? 2. Pick up 2 more 10s and bring them next door. We regroup twice. Now we're
100.
exactly. We're not regrouping a 10. We're regrouping a
100.
Excellent.
Could you send it right there?
Okay, you're right. All right, now how many 10s do we have? 2. 2. And how many hundreds are there total?
3.
323.
You're right. All right, if yours looks like mine, go ahead and wipe it. Line up your algorithm on the back. We're writing 287 plus 36. What's wrong with my algorithm?
It doesn't have an HTO.
You're right. Everybody add your HTO. Good job. Don't solve it yet. All right. Addition is fun.
It's always one.
All right. 7 in our heads. 6 on our fingers. Here we go.
7, 8, 9, 10, 11, 12, 13.
It's 10 or more.
Bring the one next door.
Exactly. All right. Here's that drill we practiced. Listen carefully. 8 plus 3.
12.
Nope.
11.
Start over. 8 plus 3.
11.
Plus 1.
12.
There it is. 10 or more.
Bring the one next door.
2 plus 1.
3.
So careful here because we had 8 plus 3, which was 11, but then we added 1. So then it was 2. 12. All right. Great job modeling addition with the discs and the algorithm. Let's do some subtraction. Flip your board over. When we add, we put both sets of discs on our mat and we compile them, we compose them, we put them together. But when we subtract, we're taking away the discs that we started with. So we only draw the minuend. So draw our minuend 282. And we're not drawing the subtrahend, we're taking away the subtrahend. All right, we always start with the
Ones place.
Jerron, you weren't listening. This is subtraction, so we only draw the minuend. We don't draw the subtrahend. We take away the subtrahend. So you should just represent 282. Now, Kirsten, stay with the team. In the ones place, we have 2 minus 6.
But you can't do it.
You can't do it. So we're going to borrow one of these 10s, cross it off, bring it next door, and what do we trade it for?
10
10 ones. Go ahead and draw your 10 ones. Now can we take 6?
Yes.
Yeah, start crossing them off. 1, 2, 3, 4, 5, 6. forget the 2 you counted up top. What's left in our ones place?
6.
6.
4.
It's not 4 because there were 4 down here from that we regrouped, but we also have the 2 from our minuend at the top. You see the 2 that we have to add to it?
Yes.
All right. All right, now in the tens place, we had 8, then we took away 1, so we had
Cross out
7.
3.
But now, yeah, we also have to take away 3. 3. So cross off 1, 2, 3. And what's left?
4.
4 is correct.
We still have left 2, so 2
2 in the hundreds place. All right. Once your discs are perfectly represented, flip it over. We're going to do the algorithm. Make sure you line it up on
ATO.
282 minus 36. Sit up. Subtraction is fun.
It's like with the 1.
2 minus 6.
Can't do it.
Yep, there's more on the floor. Go next door and get 10 more. 8 becomes 1 less.
7.
2 becomes 10 more.
12.
Good. This is a doubles. We should all know. 12 minus 6.
6.
Perfect. 7 minus 3.
4.
And 2 minus nothing?
2.
Excellent. All right, I'm going to put one up on the board. We're done with discs for today. We are only using the algorithm.
Yes.
Back in slant in 3, 2, 1, 0. I appreciate your help, but I want you to stop calling them. Line it up nice and big on HTO. 769 minus 18, and solve it by yourself. On HTO, Kirsten. Good, Bryson, clear it. Good, Maria, clear it. Good, Mark, clear it. Good, Kelsey, clear it. Denai, clear it. Dante, check your tens place. Kirby, clear it. Aaron, clear it. Darian, clear it. Terrion, clear it. Duran, clear it. Malaya, clear it.